We find ourselves in the last section of Chapter 6, Section 6.4, right before we're coming to take an exam. This homework exercise set, it could seem a lot nicer at times and then a little bit more involved at others. And so we have some good representative examples of the homework that's sketched throughout the of the homework, right? We're picking it from different places in the homework. And so we're going to solve trigonometric functions or equations involving we're going to solve equations involving inverse trigonometric functions, right? So the functions themselves are going to have sine inverse or tan inverse in there, or their answers are going to have that. So if we look to this first example that's based upon number 12 in our textbook, we start out with y is equal to negative sine x over 3 for x in what seems like a very, very strange interval. So maybe I'll talk about that first. You don't have to stress too much about this. They're picking the x in a very specific way. And actually, maybe it'd be best to show you at the end. So they're saying x has to be between minus 3 pi over 2 and 3 pi over 2. And so you'll see why in just a minute. The goal is to solve for x, right? So solve this equation for x in that interval. So let's go solve for it. So if we're going to solve for it, I need to isolate the trig term. So I'm going to multiply both sides by negative 1. And then I have to get at this x over 3. And so what I'm going to do is take the arc sine of each side. Now, because the arc sine undoes the sine, we get that the arc sine of negative y is equal to x over 3. And so what x is equal to, and this is the answer that they have in the book, is x is equal to 3 arc sine of negative y. We never know what x was until we knew what y was, and so it's got to be solved in general like that. So something should have caused you to freak out and say, hey, how did you know you could do that? And that is this arc sine operating on the sine, because if you remember from our previous sections, I think in 6.1, arc sine of maybe something like 5 pi over 6 is not 5 pi over 6. I can't just do this and write 5 pi over 6 because 5 pi over 6 is not in the outcome of arc sine. So I'd have to think, oh, this is a second quadrant angle, and or not think. Let me just not think about it. So the answer to this isn't going to be 5 pi over 6. It can't be. It's got to be something within minus pi over 2 to pi over 2. So what would we do? We could say this is arc sine. Sine of 5 pi over 6 is positive 1/2, so this is pi over 6. And pi over 6 would be the result there. So something happened here where, let me show you where here is. Something happened here where I just dropped that. That's because of this right here. That's what allowed me to do that. Notice if x is in there, that's not arbitrarily chosen. And so I'll show you with this one and just know that it's the case for the other. It's trying to force it to be in the range of the arc sine. And so what do I mean by that? Remember that we're dealing with x over 3. So if you have x over 3 and you set that equal to 3 pi over 2, what you're going to get out of that is you're going to realize that your x's, maybe that's not the best way to show that, if x is between 3 pi over 2 and negative and positive, put in x here. Look what x is like if I put in 3 pi over 2 divided by 3. Well, that's 3 pi over 2 times 1/3. That's the familiar pi over 2, both positive and negative. So what it's doing is it's forcing it to be in this range, and therefore, so x over 3 would be in this range. Therefore, you're just going to get your x over 3 straight out since it was in the range. So for example, arc sine of the sine of pi over 6 is absolutely pi over 6 because it's between minus pi over 2 and pi over 2, the output of arc sine. So it's just ensuring that we can use the arc sine as a canceller. And that's good, right? That'll help us out in that regard. So that's the work that's needed there. As we go over to this next one, equally as nice. Don't worry about that big interval. It's just trying to ensure that your x is going to work out in the proper range for tangent, namely pi over 2 negative to pi over 2 positive. So what are we going to do? First thing we're going to do is take a look at the original equation. We need to get at that x, so we're going to take the tan inverse of each side. So I'll alternate between tan inverse and arctan, or sine inverse and arcsine. The book does as well. I think most often they use the arc. And maybe that's so you don't see another number. So this is tan inverse of y is equal to, these guys will cancel because of that range, is equal to 2x minus 1. That means tan inverse y is equal to 2x. Ooh, apologize. Tan inverse y plus 1 is equal to 2x. And that means x is equal to tan inverse y plus 1 all divided by 2. And that they have in the back of the book as well. So as we go down to this last one, well, not the last one, but these last two that are on the page, let's go ahead and solve for cosine. We need to solve for x. Again, that x being from 0 to pi, that's not arbitrarily chosen. That's the output of cosine inverse. So, or arc cosine. So let's move over that 4 and divide by 3. And we right away can get to this. So you know how to get to the next piece. You're going to take your arc cosine of y minus 4 divided by 3. And that's what's equal to x. And you're finished. That's what they're going to have in the back of the book. We're guaranteed that that's going to be a 0 to pi output because of this piece right here. That's why they did it, because they knew the last thing you were going to do is the arc cosine. So if we take a look at this guy, 4 pi plus 4 tangent inverse x is equal to pi. We get 4 tan inverse x is equal to pi minus 4 pi, or 4 tan inverse x is equal to negative 3 pi, or tan inverse x is equal to negative 3 pi over 4. Now they're going to say that this has no solution. That's the symbol that they use. Equivalently, you can write no solution. Do you see why? Because negative 3 pi over 4 isn't in tangent's inverse's output. Tan inverse x has an output of between, open parenthesis, minus pi over 2 to pi over 2. And minus 3 pi over 4 is beyond that. So it's not there's no x that's going to make that work. There's no solution. There's no x who, if you took the tangent inverse of it, it would equal negative 3 pi over 4. We're throwing it out. Okay, very, very similar to when we would solve a square root equation first to get the square root isolated. We'd have a negative 6 over here. Certainly we can square negative 6, but this has no solutions because that guy's the principal square root and can never spit out a negative. This guy is the tan inverse function and can never spit out anything other than numbers between minus pi over 2 and pi over 2. Minus 3 pi over 4 is not in that range, and so therefore would never get spit out, and there's no solution. And so it gets us to really understand whether, well, to recognize, I guess, whether we really understood what we were doing before in our algebra classes, and that's awesome, right? So, what are we going to do for this one right here? Well, we're going to take the cosine of both sides. We need to get at that x. That x is locked up in an arc cosine. And if you remember, we didn't have to worry this way. If cosine was the last thing you were doing, that has no domain restrictions at all. So this is simply going to be x minus pi over 3. It absolutely will cancel, and that's why they're no longer naming any domain restrictions. Cosine of pi over 6, that's root 3 over 2. We're almost done. X is equal to root 3 over 2 plus pi over 3. Okay, maybe they'll want us to write it as a single fraction, no problem. 3 root 3 plus 2 pi all over 6. Okay, that may be what they have in the back. I would accept either answer. out of that. Here's where it gets a little bit tricky as we do these last four, really. We're going to have to draw pictures. Here they have a mixture of inverse functions, and that's when we're going to have to use one in order to know the other. They'll be related though. So here's what we're going to do first. We're going to let tan inverse of 4/3 be equal to u. So use an angle. 4/3 is positive, so it's going to be a first quadrant angle. There's no doubt about that. Here's u. Tangent's opposite over adjacent. And this is a 3, 4, 5 right triangle. So I'm going to put this 5 in. Actually, let me do it that way. Put the 5 in red. So that's going to help us out. So tangent. So we're using the fact that tan inverse of 4/3. We're going to call that u. And so let's look at what cotangent of u is. Cotangent of u then is, well, cotangent is adjacent over opposite. So I didn't even need to draw this, right? I would have known that already, but it's 4/3, so I didn't need to find the 5. I apologize about that. So what we know is that cotangent, let me go back to black. We know that cotangent of u is equal to, oh, apologize, I wrote the wrong thing. It's adjacent over opposite, so it's 3, it's 3/4. Apologize, it would be the other way. It wouldn't be the same as the tangent. So I'm just going to write this again. Cotangent of u, I'm taking it out, this is my side work, is 3/4. Let's go use that. So that means cotangent inverse of x is equal to u. Okay, now how am I getting that? I shouldn't say that meant. If I go back to the beginning, I let all of this be u. So cotangent inverse of x is equal to u. So I'm going back to the beginning. Okay, so what's x equal to? X is equal to the cotangent of u. And we know the cotangent of u is 3/4. Okay, so could have possibly handled that differently. So let's see if this makes sense to you. We're going to let u be the one thing, the angle that comes out of this piece where we know everything. There's no variables. We're going to call that u. So right away, I know cotangent inverse of x is equal to u. So I know x is equal to cotangent of u. So the only reason I'm not done is because I don't know the cotangent. But I do know that the tangent of u is 4/3. So I can use that to find the cotangent of u is equal to 3/4. Just to explain that again a different way. So 3/4 is our answer out of that. So as we go here, and we're going to essentially do the same thing. So arc cosine of x plus, well, 2 arc sine of pi over 2. Well, we know the arc sine of pi over 2. That's pi over 3 is equal to pi over 3. So now we have arc cosine of x is equal to pi over 3 minus 2 pi over 3. Well, that's just minus pi over 3 if I bring that over. They're going to say that this has no solutions because arc cosine of a value needs to be between 0 and pi. And negative pi over 3 is not in that region. So we're always respecting the range. And that's a no solution one as well. So that wasn't quite the same. Okay. Arc sine of 2x plus arc sine of x is equal to pi over 2. Let's see how we're going to do that one. So let's solve for arc sine of 2x. That's going to be equal to pi over 2 minus arc sine of x. Well, that's good. So we need to get to the x's. So what we're going to do is apply sine to both sides. So I'm going to come in here Let me do it right this time. I'm going to come in here and I'm going to apply sine to this side and sine to this entire side. So on the left-hand side, I get a nice 2x out. Sine will undo an arc sine and give us exactly that angle. Okay, so that's equal to sine of that subtraction. So we know what that is. That's sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay, so what's that? That's 2x is equal to sine of pi over 2 is 1, cosine of arc sine of x, cosine of pi over 2 is 0, times sine of arc sine is x, but essentially that's 0. So we have 2x is equal to cosine of arc sine of x. All right, that's why they had you do these embedded ones before, cosine of arc sine of x. So let's do our trick. Let's let arc sine of x be equal to u. Okay, and so here we have to do it in general. So we know that the sine of u is equal to x over 1. So that would be an x here and a 1 here. Solving for the bottom using the Pythagorean theorem, we're going to get the square root of the hypotenuse squared minus the x squared. Awesome. So what does this tell us? Well, what do we need to know? Remember what we have right now. 2x is equal to cosine, and we just replaced arc sine of x with u. So if we know what cosine u is, we could just put that algebra statement in there and never identify the angle, which is always what we want to do. Cosine of u, no problem. It's the square root of 1 minus x squared over 1. That's what cosine u is. You can see it there. And so 2x then is equal to the square root of 1 minus x squared. So guess what x is equal to? Well, let's go find out. I'm jumping ahead of myself a little bit. We need to solve for x. It's in two places, so let's square both sides. If we square both sides, I get 4x squared is equal to 1 minus x squared, or 5x squared is equal to 1, or x squared is equal to 1/5. So you know what's next. You're going to take the square root of both sides, remembering your plus or minus over here. And they won't have that. You know that. They're going to have a rationalized denominator by saying root 5 over 5, plus or minus. So you should have two answers out of that. Finally, there's this last one here. I don't know why they told us the answer was 0, but the answer is going to be 0. Let's go find out why. Okay, so with this one, why don't we set the sine inverse of x equaling the tangent inverse of x? And for lack of a better thing to do, let's take the sine of both sides. So I'll put that in red. That's going to be what I introduced, the sine of the first thing, and then the sine of the second thing. So let me come back to black and put in sine of sine inverse of x is equal to sine of tan inverse of x. Well, this is just x, so it's very similar to what we just did. Feels a little bit weird. Definitely look at the book examples as well. They'll explain it a different way potentially, which will be helpful. So we need to figure out what tan inverse of x is. So let's let tan inverse of x equal u. Now we don't need to find out what it is. We need to get a graphical representation. So here's u, and the tangent is opposite over adjacent. And so if we did the Pythagorean theorem, that would be the square root of 1 squared plus x squared. And so we get a 1 plus x squared in there. Now why is that so important? Because look what x is equal to. X is equal to the sine of u. Well, we can see what the sine of u is. X is equal to, well, what is the sine of u? It's opposite over hypotenuse. Easy, right? And so now we got to solve. So I personally would get that square root up out of the bottom and bring that x over. because we have x's that we can't get together, so we're going to hope to factor. X times 1 plus root x. Whoops, sorry. Didn't write that right. And let me see if I can scoot over just a little bit. I can. So we'll come right up here. And so I'll factor out an x and be left with the square root of 1 plus x squared minus 1 is equal to 0. And let's take a look. Oh, I made a mistake in the very beginning. Probably drove you nuts. When I moved that tangent over, it should have been negative. So I just saw that when I looked back at the original problem. We would have been fine if that was tangent, if that was a minus sign here in the beginning, but it wasn't. So do remember that there's only one adjustment that needs to take place. Sine's an odd function, so we're going to bring that negative outside here, which means that there's going to be a negative here, which means there's going to be a negative here. And so when I bring that x over, it's going to be a positive, and this is going to be a plus 1. We would have been fine either way. So what do we have? We have x is equal to 0. Okay, that's one answer. Or square root of 1 plus x squared plus 1 is equal to 0. But that won't happen, because that would mean square root of 1 plus x squared need to be equal to negative 1, and it can't happen. So there's only one answer that comes out of that, 0. And so if somebody just wrote 0, I couldn't give them any credit, because we need you to go through the algebraic justification rather than guess and check. But only 0 is the answer to that one. This is the work that you're doing in 6-4. It is new and exciting, but that's why you have the whole week to kind of ascertain that, and your exam isn't until next week, and your homework's not due for a while. So don't expect instant answers. Struggle through some of these things, try different things, watch it go a different way. Try not to be frustrated with it, because the more time you can have with your hands on trig, the better it will be now and in the future.